Hi guys, this is the last lesson in the chapter 8. This lesson is about fundamental trigonometric identities. In this lesson, we're going to learn some fundamental identities about trigonometric function. Trigonometric function, you know, is sine, cosine, and tan. Okay, here we have some identities about them. Here we have tan. Tan is equal to sine over cosine. We know this. And guys, just know this. Tan is equal to sine over cosine, and sine squared theta plus cosine squared theta is equal to 1. Then we will just bring this cosine there by negative side. We will get sine squared theta is equal to 1 minus cosine squared theta. Then by putting sine squared theta into another side of the equality, we will get this rule. It means just you have to know tan is equal to sine over cosine, and sine squared plus cosine squared theta is equal to 1. This is really easy, and we needed this so much in your grade and grade 11 a lot. Now, what about this rule? Guys, you have learned this rule in the previous lessons. R squared, this is Pythagoras rule, you know this. And you know this sine theta is equal to y over r. And cosine theta is equal to x over r. Tan theta is equal to y over x. You know all of this. Now, let's solve these examples about it. Guys, we need these fundamental identities and these rules. Okay, in this example, prove identity sine squared theta plus cosine squared theta is equal to 1. How we can prove it at the first? At the first, for proving every rule or everything, you have to take one of the complex side of your rule. Then you have to get another side. How? Look at here. We have two sides. This is equality in the middle. We have two sides. This side and the other side. Which side is complex? Of course, sine squared theta plus cosine squared theta. Okay, let's take this side. So after proving, we have to get 1. Now, look at here. Sine square theta plus cosine sine square theta plus cosine square theta is equal, sorry, don't write equal, this is wrong. Now, what is sine? We know that sine is equal to y over r, right? And we know this cosine is equal to x over r. Just we have to substitute instead of sine and cosine. Okay, now sine squared theta, just write y over r square plus cosine squared theta, just write x over r square. Solve it. We can share this square into the bracket. This is become 2y, y square over r square plus x square over r square. Guys, here we have two fraction. In this two fraction, we have to add it. So we have the same denominator. Just write one denominator is r square. Then add numerator y square plus x square. Now stop here. Guys, we know this r is equal to x square plus, r square is equal to x square plus y square. We know this, right? So here we can substitute instead of y square and x square, we can substitute it r square. Why? Because r square is equal to this form. So here we we can say we get r square over r square. So r square over r square is equal to 1. Look at here, guys. 1 and 1. Enough. Okay. This is our proof is over. This is really easy. Let me show you this one. Prove the identity tan square theta plus 1 is equal to 1 over cosine square theta. Guys, I told you every time take the complex side. The complex side here is tan square theta plus 1. Okay, let's write it down here. Tan square theta plus 1. We have to get 1 over cosine square theta. Okay. Now, guys, we know that tan is equal to what? Y over x. We know this all. Okay. Now, tan square theta, instead of tan, substitute 1 y over x square plus 1. Okay. You can share this square into the bracket. This is become 2 y square over x square plus 1. Guys, here we have a number plus a fraction, so we have to find common denominator, right? For finding common denominator, we have to multiply this term by the denominator x square multiplied by x square and x square. Okay, now write it down. This is become 2 y square over x square plus x square over x square. Now we have the same denominator. Write it down, one of them, x square y square plus x square. Then you have to add numerator. We will stop here again. Why? Because we know this again. R square is equal to y square plus x square, right? Now, instead of x square and y square, we will substitute r square. Okay, now we will finish it here. R square over x square. Now, r square over x square, we will stop it here. Before this, guys, look at here. We know this sine is equal to what? Y over r. What about cosine? Cosine is equal to x over r. So here we have r over x. So if we have r over x, it means we have 1 over cosine. 1 over cosine theta is equal to r over x. Just flip it. And here we have square. Just added a square for them. So this is really easy. R square over x square, this is equal to 1 over cosine square theta. This is the other side of our identity. Okay. What about this one? In this one, in this question, in this example, it said write sine square theta over 1 minus cosine theta in terms of a single trigonometric function. Okay, single trigonometric function. This is not proof. This is we have to solve it or write it or convert it by a single trigonometric function. Guys, here we have 2 trigonometric function, sine and cosine, but we don't want this. We want identity by but this identity contain only a single trigonometric function. How we can do this, guys? It depends on this rule that we have learned in the first of our lesson. Okay, let's write down this question again. Sine square theta over 1 minus cosine theta. I will remind you the rules. Our rules is, at the first I told you tan theta is equal to sine over cosine, right? Then I told you cosine square theta plus sine square is equal to 1. By putting sine there, cosine square theta is equal to 1 minus sine square theta. And if sine is here, sine square theta is here, then this is become to 1 minus cosine square theta. Just we have these rules, guys. By using this rule, we can solve this question. How? Just look at here. Look at here. Here we have sine square theta, and here we have sine square theta. We can substitute it with it. Okay, this is equal to, instead of sine square theta, you can write 1 minus cosine square theta over 1 minus cosine theta. You can simplify it again. How? Guys, 1 minus cosine square theta, you can write it by a 2 bracket. We have learned this from the first course. 1 minus cosine theta, 1 plus cosine theta, over, write down 1 minus cosine theta. We can cancel 1 minus cosine. So this question is equal to 1 plus cosine theta. This is our result. This is a form which contains a single trigonometric function just by using these rules. Okay, now what about this example? In this example, we have the same idea. You have the same idea. This is really easy. Here we have cosine square theta, guys. Look at here, cosine square theta. And instead of cosine square theta, we will use 1 minus sine square theta. Let's solve it here. Okay, this is equal to 1 minus sine square theta over 1 minus sine theta. And this is equal to 1 minus sine theta, 1 plus sine theta over 1 minus sine theta. You can cancel it. This is equal to 1 plus sine theta. This is the same question. Look at this question, guys. I bring this two question with your exercise. Write each expression in terms of a single trigonometric function. Okay, let's write these two questions. The first question, the question 11. Question 11. Here we have tan theta over sine theta. At the first, you know this tan is equal to sine over cosine, right? Okay. By using this in your question, you can solve it. Sine over cosine, tan is equal to sine over cosine. So you can use this instead of tan, sine theta over cosine theta over right sine theta. Now, here we have this division. This is fraction, but you can write it like sine theta over cosine theta multiplied by 1 over sine theta. Then cancel this sign. Our question is equal to 1 over cosine theta. Okay, what about this one? Again, we have the same idea. Instead of tan, we will write sine theta over cosine theta over all over cosine theta here. Now we can write it like here, like this previous example. You can write just like a multiplication, sine theta over cosine theta multiplied by 1 over cosine theta. We can't cancel it, but this is become 2 sine theta over cosine square. We have 2 cosine. You can see cosine square theta. And we know this, guys. Cosine square theta is equal to, write down sine theta. Cosine square theta is equal to 1 minus sine square theta. This is our solution. And this was the last chapter and the last question. I hope it is all clear for you, and I hope you are be successful with the math. Thank you for watching and listening.